Good day, everyone. My name is Venice Margaret Lorejas, a grade 12 STEM Newton student, and today I will be discussing on how to balance a chemical equation. The law of conservation of mass states that no mass can be lost as a result of a chemical reaction. Chemists express these ideas in chemical shorthand by writing the reactions as what we call chemical equations, in which conservation of mass is implicitly noted by an arrow separating components which react, called reactants, from components resulting from the reaction, called products. Chemical equations follows the law of conservation of mass, in which the total mass of the products is equal to the total mass of the reactants. Therefore, chemical equations must be balanced. Let us have an example. Perchloric acid and Tetraphosphorus decoxide react to form phosphoric acid and dichlorine heptoxide. The first thing we need to do is to translate the chemical statement into a skeleton equations. Write the correct formula of our reactants, which is perchloric acid and tetraphosphorus decoxide, and place it on the left side of the arrow. Also write the formulas of the products and place it on the right side of the reaction arrow. We have perchloric acid and tetraphosphorus decoxide yields phosphoric acid and dichlorine heptoxide. At the beginning of our balancing process, we put a blank in front of each formula to remind us that we have to account for its atoms. To avoid confusion, I also draw a line to divide the reactant side to the product side of the equation. After that, list down all elements present in the reactant. Do the same process for the product. So we have here phosphorus, chlorine, hydrogen, and oxygen. Count the total number of atoms of each element in the reactants and in the products by looking at their subscripts. So we have here on the reactant side, we have phosphorus is equal to 4, chlorine is equal to 1, hydrogen is equals to 1, and oxygen is equals to 4, plus 10, we have a total of 14. Do the same thing for the product side. So we have phosphorus is equal to 1, chlorine is equals to 2, hydrogen is equals to 3, and then we have oxygen is equals to 4, and another one is equals to 7. Next thing we need to do is to balance the atoms. So by shifting our attention back and forth, we match the numbers of each time of atom on the left and the right of the yield arrow. So in each blank, we place a balancing coefficient, a numerical multiplier of all the atoms in the formula that follows it. Note that we must not attempt to balance the equation by changing subscripts in chemical formulas. So simply, we will just change the coefficient. In balancing the elements, it is best to begin with elements other than hydrogen and oxygen. So, we will balance the phosphorus first. There are 4 phosphorus atoms on the reactant side and 1 phosphorus atom on the product side. Is the number of atoms the same? No, not yet. That's why we will be placing a coefficient. So since the subscript of the reactant of phosphorus is equals to 4, how about placing a coefficient for the product, which is 4? So let's try it. Phosphorus is equals to 1 times 4 is equals to 4. So since 4, how about we put 1 as coefficient for the reactant side? So 4 times 1 is equals to 4. Is it already equal? Yes. We already balanced the atoms of the phosphorus. Then we will proceed by multiplying the remaining elements to the coefficient 4. So we have hydrogen is equals to 3 times 4 is equals to 12. And then for oxygen we have 4 times 4 is equals to 16. Do the same for the reactant. Oxygen is equals to 10, so multiply it by coefficient 1. We have 10 times 1 is equals to 10. Since the hydrogen on the product side is equals to 12, how about placing a coefficient of 12 for perchloric acid? So we have hydrogen is equals to 1 times 12 is equals to 12. So finally, our hydrogen is already equal to each other. So let's proceed by multiplying the same 12 coefficient to chlorine and oxygen. So we have, for chlorine, subscript of 1 times 12 is equals to 12. And then for oxygen, 4 times 12 is equals to 48. So 48 plus 10 is equals to 58 oxygen atoms. To find the coefficient for dichlorine heptoxide, we need the least common multiple of 2 and 12, the LCM or the least common multiple. So the LCM of 2 and 12 is 6. So how about we try placing 6 as our coefficient? So let's try. So chlorine is equals to 2 times 6 is equals to 12. Since the total number of chlorine atoms on the reactant side is equals to 12, then we already have the same number of chlorine atoms on both sides. So let's proceed by multiplying the oxygen by the coefficient 6. So we have oxygen is equals to 7 times 6 is equals to 42. Then we simply add 42 plus 16. We arrive with total of 58 number of oxygen atoms. And it's the same to the total number of oxygen atoms on the reactant side. After balancing and adjusting the coefficient, let's check each atoms to be sure that the equation is correctly balanced. So let's start with the phosphorus. So in the reactant, we have phosphorus is equals to 4 times 1 is equals to 4. And on the product side, we have 1 times 4 is equals to 4. So check. Next, we have chlorine. For the reactant, we have subscript of 1 times 12 is equals to 12. Then for the product, we have 2 times 6 is equals to 12. Check. Next, we have hydrogen. Hydrogen is equals to 1 times 12 is equals to 12. On the other side, we have 3 times 4 is equals to 12. So check. For oxygen, we have 4 times 12 is equals to 48 plus 1 times 10 is equals to 10. So 48 plus 10, we have 58. How about on the product side? So we have 4 times 4 is equals to 16 plus 7 times 6 is equals to 42. So 42 plus 16, we have a total of 58. Our chemical equation is already balanced. However, let's not forget our last rule, which is to make sure that all of the coefficients are reduced in the lowest possible whole number ratios. So can we reduce the coefficient 12, 1, 4, and 6? No. So again, we already have our final answer. So the balance equation therefore is 12 perchloric acid plus 1 tetraphosphorus decoxide yield 4 phosphoric acid and 6 dichlorine heptoxide. And that would be all. Thank you.